Hi, my name is Stuart Penninger. I'm joined by my colleague Megan Banaski, and today we'll be talking with you about real-time GIS. We'll take a look at two different solutions, Geoevent Server and ArcGIS Velocity, and how they handle real-time data. Here's the agenda for the next 30 or so minutes. We'll cover what real-time GIS is. I will do a brief overview of what Geoevent Server is and some of its key capabilities. Then we'll transition to a brief demonstration about tracking drones and building out a Geoevent service. And finally, I'll pass it over to Megan, who will cover ArcGIS Velocity. What is real-time GIS? The world is dynamic. Events are constantly in motion, always changing. Real-time GIS tracks these changes and assists with mapping movement, value change, or recording an entirely new event. We break down real-time data into three categories: fixed assets, things that move, things that just happen or occur. Inside of the ArcGIS platform, we have two ways of handling real-time GIS. I'm going to show you one of these options, Geoevent Server. Geoevent is the enterprise real-time GIS ingestion and analysis platform. It ingests high volume and high velocity data streams. It provides streaming analytics to process and analyze your real-time data. Geoevent is built on a Geoevent service. The service defines the flow of real-time data from an input through optional filters and processors to an output. Real-time filtering and processing are applied to event records as they flow through a Geoevent service. The first key capability of Geoevent is the numerous connectors. Geoevent can draw from a whole host of data streams and processes data so it can be ingested into your enterprise. Once data is ingested, real-time analytics can be run on the data. We can configure processors or filters to better understand our data. We can buffer incoming data on incoming geometries or enrich it with other data located in our enterprise. Your incoming data, once it has been interpreted by the input and run through a processor or filter, can be sent out in numerous different ways. It can be sent to a stream service, which is a unique feature of Geoevent. Or if you're looking for alerts and emails or a text, those can also be sent to a commander or a site supervisor. When you visualize your Geoevent output and a map, points will move, sensors will change value, and stream services offer unique visualization options not available to a typical feature service. Now, we'll take a look at tracking drones over Djibouti and building out a Geoevent service. Before we get started, it is important to note this is a fabricated scenario and exercise. This dashboard shows drone flight situational awareness over Djibouti. Djibouti has recently become a theater of geopolitical competition. The United States has drone bases there, China just built its first overseas military base, and a brand new port. That is not to mention there are French, German, Italian, and Japanese interests at play as well. Tracking drones in real time to monitor their positions is an essential function of any commander stationed there. Using Geoevent, drones can be monitored throughout their entire flight, and critical information can be relayed to decision makers when a drone enters a geofence. We have geofence two areas, the Chinese naval base and the border with Somalia. When a drone enters that area, a warning will be returned in the dashboard. While the drones are in flight, let's look under the hood to see the Geoevent service powering this dashboard. This is the ArcGIS Geoevent Manager. When you log in the Geoevent Manager, this is the page you'll be taken to. Before we construct a service, let's take a look at a fundamental building block of any Geoevent service, a Geovent Definition. Navigating to our Site tab takes us to the Geovent Definition page. A Geovent Definition is the basis for how incoming data is interpreted. The schema of your Geovent Definition must match the incoming schema of your data stream. They must match exactly or the data cannot be ingested correctly. There are two ways to add a Geovent definition. If you know the incoming data structure, then you can create a new one yourself and label the fields appropriately. You can also import a schema from your enterprise. Here, I'm connected to my enterprise to a registered ArcGIS server and can view all my content items that are available for import. I've already added the definition we're going to use. Let's examine it and note some of the key aspects. I can add new fields or reorder the current fields. Each field has a type associated with it, and most importantly, there are tags associated with key fields. Our platform name is the track ID, which is the unique identifier for the incoming GeoEvent. The time start is our date and time field accompanying the specific GeoEvent. The last is the construction of a geometry field. We have a longitude and a latitude. When the longitude and latitude flow through the GeoEvent, the geometry will be constructed, combining the longitude and latitude with a spatial reference. A typical web map has a spatial reference of 4326. When we examine the incoming data later on, the longitude and latitude will be combined with this spatial reference to create a point on a map. One of the highlights of GeoEvent is the ability to geofence areas or points for real-time alerting. Inside of the Site tab is the Geofences list. Just as we imported the Geoevent definition from our enterprise, we can import Geofences as well. Importing a simple polygon feature class allows for Geoevent to determine what areas are considered restricted airspace. Using the Geofence viewer allows for quick inspection of our geofence to make sure it is in the right place over the Chinese naval base. Now we have our Geoevent definition and Geofences squared away, we can build our Geoevent service. Returning to the manager page, we'll add a service and give it a name. When the service is created, we'll be taken to the Geoevent Service Design canvas. One easy way to think about this page is to compare it to Model Builder. If you've ever used ArcGIS Pro or Desktop, you've probably created a model with the drag and drop functionality. The Geoevent Service Design canvas works similarly. From the New Elements pane, dragging in an input will prompt us to select any number of options. We can pull a feature service on ArcGIS server, we can receive a GeoJSON on a WebSocket, or pull an external website or REST endpoint for features. We can also monitor a folder that is regularly updated with new CSVs, so when an update is available, it will pass through our GeoEvent. The input for this has already been constructed. Let's take a look at it. There are key choices in the Advanced tab. We can create a Geoevent definition and construct our geometry as seen in our Geoevent definition. Now that we've constructed our geometry and made sure of our spatial reference, this input is ready to receive data. Next, we'll need to add an output to complete our Geoevent service. Similar to the input, a simple drag and drop will provide us with multiple options. We can update a feature service or send features to a stream service, a unique feature of Geoevent. Or if you want to be alerted or informed of new events, an email or text message can be sent out. We've already created the output. Let's go ahead and add it. To monitor drones over the Chinese base, we'll publish a feature service to our enterprise. You can do that directly inside of Geoevent. Now that we've published a feature service, we can access that item through our portal in our content. Now this would be enough for a complete Geoevent service, but we haven't utilized any of the analytical capabilities. Let's drag a processor in and rectify that. Inside of Geoevent, there are over 20 different processors to choose from, including the ability to buffer geoevents or enrich the incoming data with information from a CSV or feature service. We'll use the incident detector to determine whenever a drone enters restricted airspace. Give the processor a pertinent name and then select the opening condition to specify when an incident should be opened. Add the expression. We're looking for geometry intersection. The drones are a point while the geofence is a polygon. Anytime that point intersects with a polygon, we want an incident to be returned and we want to be notified. In field, select geometry, and in operator, select intersects. When we make the change, The owner ID will change to the geometry and the geofence option will automatically populate. Select your preferred geofence, in this case, the Chinese naval base. You can leave the closing condition blank because it assumes the inverse of the opening condition. Change severity to warning and select OK. Connect the input to the processor and the processor to the output. Hit Publish, and now you have a complete Geoevent service. This is only a portion of the full Geoevent service powering that dashboard. Let's take a look at the complete product. We built the middle tree of the Geoevent service. We are writing out to 3 different feature classes to determine what drones have passed through Somalian airspace, the Chinese naval base, and where the drones currently are. Using the sample route ability, we ensure our Geoevent is flowing correctly. And with the event viewer, we don't have to leave Geoevent to visualize these on a map. We've constructed a Geovent definition, imported Geofences, created a Geovent service, and visualized the data all in one platform. Geovent is the enterprise solution to solving real-time GIS. I am now going to pass it over to my colleague Megan, and she will show you ArcGIS Velocity.
Thank you, Stuart. You just saw from Stuart how to ingest, analyze, and visualize real-time data in the ArcGIS GeoEvent Server hosted on your enterprise. Today, I'll be introducing ArcGIS Velocity, an ArcGIS Online software as a service or SaaS solution that is hosted and maintained by Esri. All you need is a web browser to ingest your feeds of data coming in at high speeds or volumes. I want to start this out by talking about the differences between Geoevent Server and ArcGIS Velocity. Geoevent is a server role hosted and maintained by your organization on your enterprise, while ArcGIS Velocity is a SaaS solution hosted and maintained on ArcGIS Online. So those responsibilities don't need to be handled by your organization. Geoevent Server has over 20 input connector options, mostly focused on web sources in formats like JSON, GeoJSON, XML, or CSV, over WebSockets and web APIs, as well as the ability to either find or develop your own connectors for virtually any data source. ArcGIS Velocity currently has less input connectors, because it's mainly focused on those IoT and cloud sources. Lastly, Geoevent works well with GeoAnalytic Server to complete big data analytics, while ArcGIS Velocity is hosted on and uses cloud infrastructure for processing, allowing it to support higher volumes and velocities of data. While they have their differences, they're both designed to ingest, analyze, alert, and act on your real-time data. ArcGIS Velocity is best suited for feeds from the Internet of Things, or IoT sensors, and cloud sources. Some examples of tasks that can be accomplished using ArcGIS Velocity range from personnel tracking to asset and entity tracking, to operations monitoring, anomaly detection, and so much more. Across all these use cases, to really take advantage of the data being produced by sensors and IoT devices, you need to be able to do 4 fundamental things. Ingest data being broadcast by the sensors, which in some industries is coming in at higher and higher velocities. Analyze that data to get insights from either real-time or historical big data. Trigger alerts as that data comes in, and take action when necessary. ArcGIS Velocity sits on the edge of Esri's geospatial cloud and complements Internet of Things platforms by enabling you to easily bring sensor data into ArcGIS for analysis and dissemination. There are a few new types of items in ArcGIS Online that allow you to work more efficiently with ArcGIS Velocity. Feeds allow you to receive sensor inputs in real time. Real-time analytics allow you to perform real-time processing on those inputs, including triggering alerts and actions. And big data analytics allow you to access and analyze big data repositories of historical observations. These analytics can then produce feature layers, stream layers, and map image layers to be used throughout the ArcGIS platform, as well as in APIs or desktop applications to provide additional context and situational awareness. And with that overview, I'd like to show you how easy it is to create a feed and real-time analytic in ArcGIS Velocity and visualize those results in ArcGIS Dashboards. For this demonstration, we'll be using an API from the LA Metro, showing the locations and other information about buses currently running on their routes. This is the ArcGIS Velocity homepage, which sets you up for success from the start. It'll show your recent tasks, quick guides to getting started with feeds, real-time analytics, or big data analytics, as well as quick links to help topics for creating or designing these feeds and analytics. We'll start today by creating a feed. There are a few options to choose from when creating a feed in ArcGIS Velocity. We can create a feed from a feature or stream layer, a cloud service like Azure or Amazon, as well as web and messaging, which is what we'll be focusing on today. We'll choose to pull an HTTP puller and use the endpoint from that API to pull all of the buses currently running on their routes. For this example, we'll ignore the advanced options. However, just note that you can change the HTTP method, add authentication, and change your URL parameters or custom headers. By clicking Next, ArcGIS Velocity will automatically sample a few values from our endpoint. But we can see right away that this isn't exactly what we're looking for. It looks like items is the root node of our data. So we'll add that in as the root node and once again derive that schema, which will sample a few values and show us examples so we can make sure our data is correct. A few fields we want to note here are the longitude and latitude, which we'll use to build our geometry in the next step, as well as seconds since the last report, which we'll use in our analytic to determine the date that this was reported, as well as the run ID, which will be the unique ID for each of the buses on our route. Now we'll start to build out that location with those XY fields that we saw when our data was derived. So we'll use longitude and latitude and enter a spatial reference. And then we can move on to the date. Now we currently don't have a date in our fields. As I mentioned, we have the second since last report, which we'll use in our analytic to determine that date field, and we can add it in once we do that. And lastly, the track field will be that run ID for each of the unique buses. We'll set this to run every 15 seconds so we can stay up to date on the locations of our buses. And we'll name our feed. By creating this feed, it will initialize and start. And once it's started, we'll be able to see the data populate in the map field below. And now that this is initialized, we can zoom in and start to see our data moving through our feed in real time. We'll move now to creating a new analytic. We'll start by adding an output to this analytic. There are a few options in ArcGIS Velocity to do this. We can choose to output to an ArcGIS feature or stream layer, send data to a cloud service, or choose web and messaging, whether that's an email, a text message, or through HTTP. For this example, we'll be sending our data to a feature layer. This is one of my favorite parts of ArcGIS Velocity because it's so easy to create this new feature layer with the schema from our feed. We'll choose to keep only the latest feature for each unique track ID and keep the existing features in schema. We'll return this data for one day and choose not to export it. And lastly, we'll give this feature layer a name. Now that we have our input and output, we can choose to create our analytic. And once this is created, we can move into a model view similar to what you saw Stuart show with the design canvas or what you see in Model Builder. So we'll toggle to that model view, and now we have our input and output. We'll add some space for the processor that we're going to add. And we have a few options for processors we can use in ArcGIS Velocity. We can find locations, manage data, summarize data, or use proximity. Now I mentioned that we have the seconds since our last report, so we'll use that to calculate a field in our analytic. We'll connect our input to our calculation and double-click that to start to add. We'll name our field reported date, and that will be a date field, and then we can start to configure our arcade expression. We'll use the date add function and the current time. We'll actually be subtracting the field from our feature that contains the seconds since our last report. And we'll just define that it's seconds we're looking to subtract. We can test this and see that we have a date returned. Press OK, and then add that to our calculate field function. And lastly, we'll just apply it. Now we can connect the calculate field to our output, and we have a simple analytic to calculate that field and output it a time-enabled feature layer. However, we can also take this a step further and add a few more processors, another layer, create something that looks a little bit like this. So from here, we're taking in our feed of buses, calculating that date field, and mapping it so that we can define it as our date. We'll output that into a feature layer, but we'll also import our bus lines. So this will be each of the routes that the buses are taking. And we can then start to look at where any of those buses start to deviate from their routes. Now this could happen for a number of reasons, whether they're done with their shift, taking a detour, but it could also mean that something's gone awry. So we'll output those incidents so that we can visualize them in a dashboard. Looking at this dashboard, we see that there are currently 341 active buses in the LA metro area. We can also see that 98% of these buses are on their route. However, if we want to dig a little deeper, we can start to look at those buses that are not on their route and see what's going on and if we need to do anything about it. If you had the historical data of the tracks of those buses that deviated off of their routes, you could take a look at using a big data analytic in ArcGIS Velocity to reconstruct the tracks and look at where each of these buses went and at what time. Here are a few additional resources to help you with getting started in your real-time GIS projects. And we want to thank you so much for joining us today for this session.